Welcome back to the shop. It's time to get to work on the upper section of the LOC Patriot, but first, you might have noticed I don't have my background anymore. That was a wing for a Vans RV7 home-built airplane. I had been working on it for a while, and then in the last several years I just hadn't gotten that much work done on it. I had a tough time justifying all the time and expense to put together a two-seat airplane when I have a four-person family. So I sold the RV7 project, used the funds to equip a new game room in the house, and now I have to figure out a new background. So my plan is to make a nice rack for displaying the rockets that I've built. So that should be coming up in the next few videos, hopefully. Anyway, let's get to work on the LOC Patriot. Looking at the upper section as it comes from LOC, you have a plastic nose cone. You have the upper section body tube here. This is the payload tube. You have a coupler, and you've got a bulkhead with attachment hardware right here. Now, if you were to fly the rocket with motor deploy, you would probably want to glue the nose cone on permanently. Then you would glue on the coupler permanently. This would become your shoulder and separation point. And of course your bulkhead would be glued into the coupler. But I'm not going to do that. Instead, I'm going to convert this rocket for dual deploy using an altimeter controlled deployment for the parachutes. So in a previous build I talked about how I was going to convert it to a single breakpoint dual deploy. And that was kind of a wrong term to use. What I should have said was vent bandless breakpoint. So instead of there being a vent band here on the coupler for the avionics bay, there's going to be no vent band at all. And I'm going to have my vent holes here in the payload tube going through the avionics bay. So I'll show you how to do that. It works great. It looks, in my opinion, it looks a little bit better on the rockets because there's only one breakpoint in the body tube instead of two. I'm going to start by taking some alignment marks, taking some measurements in order to prepare for converting the avionics bay tube into a removable attachment to the payload tube. So just to start with, I'm going to make a straight line going up the payload tube here, and this will end up being the back of the tube. This will line up with the rail buttons. It's also where I'm going to put my vent hole. I'm going to use this as well as a starting point for making the drill holes for the screw attachments, as well as the vent band for the vent holes. Now, looking at the coupler here, since this is going to be sliding into the booster tube, we know that typically we like to see at least one caliber of distance going into the main tube. So in that case, it would be 5.5 inches. And since the top part's going to be fixed, this doesn't have to be one full caliber. So I'm going to just give a little bit of extra space there. We're going to make 6.5 inches of shoulder length going into the payload tube, and that should keep it nice and steady. With this measurement figured out here, I'm going to set up the distance for the screw holes and the vent tube holes. So I want enough space between the edge here and the edge here. So we have enough edge distance here, and I figure having all the holes be 2.5 inches up from the bottom of the payload tube will be a good measurement. So I'm going to make that mark right here on the payload tube, and then we'll get to work marking the rest of the holes. Just like with my polecat builds, I'm planning on making 6 holes that go around the circumference of the payload tube, and they'll all go into the avionics bay. 3 of the holes will be for the number 8 screws to hold the 2 tubes in place, and then the other 3 holes will be for the actual vent and access to the screw switches for turning on the altimeters. So to get the holes spaced out evenly, what I'll do is I'll get an accurate circumference measurement, and I use that by taping a couple pieces of paper together, wrapping them around the rocket, and then making a mark here. So I can take the paper apart, and what I'll do is I'll get a measurement on what the actual circumference is. Then I'll just simply divide that by 6, and I can mark the holes appropriately. So just using millimeters here, I'm showing 442 millimeters. So I'll just divide that and make 6 marks equally spaced all the way around. So for equal spacing on this circumference, we're looking at 73 2/3 millimeters between each mark. So I'll just mark each point here, and then we can transfer these marks to the body tube. Alright, with my marking guide back in place, I can Simply transfer the hole locations over to the payload tube here. And this is just for alignment here, and I'm going to come back with my ruler to make sure they're all 2.5 inches up from the bottom. There we go. I'm going to start drilling the holes to connect the payload tube with the av bay by drilling a hole for the first screw that's going to go in. Now this is my aft line here, and on the back of the rocket this is where the rail sits, so I don't want a screw head sticking out. So this is going to be a vent hole here. This one's going to be my first screw hole. So I'm going to put the av bay in right up to my alignment mark here. That'll work right there. And I'm going to drill a pilot hole . After drilling the pilot hole, I'm going to step up to the full-size hole for the number 8 screw. This is an 11/64 drill bit. With that hole drilled, I'm going to install the screw, and I'm going to set this whole assembly up on the booster tube, and that way I can make sure that the payload tube is sitting straight on the booster tube, and I'll drill my remaining 2 screw holes. Okay, with the payload tube sitting on top of the booster section, I can make sure that both the tubes are aligned and sitting straight, and I'll continue to drill the holes for the next 2 screws. And as I go with each hole here, I'm going to drill it out to full size, and I'm going to pin it with the screw. So here's the second screw installed. Okay, there's the third screw installed. Now since I have the rocket put together and I have the Avionics bay pinned in place, I'll go ahead and drill the holes for the vent. Because the Avionics bay is pinned in place right now and not going anywhere, I can just use my pilot drill for all 3 of the holes first and then come back and enlarge it to full size. And for this rocket I'm going to use 7/32 of an inch final size for the vent holes. This will be plenty big for this diameter of a rocket, and it'll allow me to fit my screwdriver in through the hole easily to turn on the MissileWorks screw switches. Since I have the payload tube attached to the booster tube right now, this is a great time for me to mark and drill the location for the shear pins. So just going 1/4 away around the body tube on each side, and because the Avionics bay is 6.5 inches long shoulder-wise going into the main body tube, I'll drill the holes 5.5 inches down from the top. So just like the Avionics bay being attached to the payload tube, I'm actually going to tap and pin the first hole before drilling the second hole. This will ensure that nothing shifts while I'm drilling the second hole. Now, I like using shear pins when I'm using altimeters for deployment because I can ground test and triple check the amount of black powder that I need to get a successful separation between the payload tube and the booster tube. If I was just flying this rocket stock using motor deploy only, I would use friction fit for the connection here. There, with the first pin in, I can drill the second hole, and I can tap and pin that, and that will complete the booster section. I can get that off for paint. There we go, there's both shear pins for the booster tube to the Avionics bay all set. Another item to take care of in the payload tube is a pressure relief hole. I'm just using a 1/8 inch drill bit here. The only important thing to remember about the pressure hole is to make sure that it's not at the same point as the nose cone shoulder. Before I remove the coupler from the payload tube here, I'm just going to extend the alignment mark down onto the coupler so I know which holes line up with which as much as I try and space out the holes as perfectly as I can, they are going to be slightly off. This way, when I align the marks, I know that I'm lining up the proper holes with each other. Okay, with all the screw and the vent holes drilled in the payload tube here, I'm just going to remove all the screws. Then we'll pull out the coupler, and we'll get to work on attaching T-nuts to backing wood, and then we're going to glue the T-nuts on the inside of the avionics bay tube. Because cardboard doesn't drill quite as cleanly as fiberglass, I like to take some either thin or medium CA. Just come back and wick the holes that I've drilled. This will help clean them up a little bit and add some strength. And after this glue dries, I'll come back with some sandpaper and sand the extra cardboard down, and then drill the hole one more time just to clean up the hole. So I'll do that with all the holes that I've drilled on this rocket. To give the payload bay screws something to thread into to couple to the avionics tube, I like to just take some T-nuts and put them into wood and then glue that on the inside of the avionics bay. So what I'm doing right now is I'm just lining up some T-nuts on a piece of scrap 1/4-inch plywood, and I'm just marking where I'm going to drill the holes. And then we'll put the T-nuts into this wood, split it apart, and then sand it down so there's not too much extra weight there. And then we can install that inside the avionics tube. Once the CA glue hardens on the holes that you've drilled in the avionics bay, it's good to come back with some sandpaper and smooth out the holes. Then you can re-drill them to make sure the holes look real nice. So here's the T-nut installed into the block and cut apart from the 1/4-inch stock. I also sanded a little bit of a curve onto the front side of it here. Now I'm going to glue it inside the avionics bay. And to do that, I'll put some white glue on it, and I'll just put it in place with a screw. And normally when I put the rocket together for flight, I don't use a washer to hold the avionics bay on, but just for installing these blocks here, I do use a washer to help spread the load out onto the cardboard surface. So fortunately, just being a cardboard and wood rocket, I can use wood glue for this, and I don't have to worry about the screws sticking inside the block like I would if I was using epoxy. So I'll just put the block in place, put a screw on, and simply screw it down, and that'll hold the block in place, and we'll let the wood glue dry. Okay, all 3 of the blocks have been installed, so we'll just let that dry for a while. Now that the blind nuts are installed in the avionics bay coupler, I need to make a couple bulkheads. So the first bulkhead that I'm going to make is the same dimension as the bulkhead that comes with the kit. This one fits inside the coupler, and this will center up the bulkhead on the outside. So to use that, I'm going to use my fly cutter tool. I've set the distance on the fly cutter to be the same as the bulkhead that comes with the kit, so I'm going to cut one of these right now. Okay, so here's the bulkhead that I just cut out. Just took a small amount of sanding to get it to fit inside the avionics bay tube. So now what I'm going to do is set the bulkhead inside the tube, and I'll adjust the depth on my fly cutter here for the outer bulkheads. With all the bulkheads cut, I simply need to glue the outer bulkheads into the inner bulkheads here. For that, I'll just use some wood glue here. Doesn't take a whole lot. These bulkheads are always going to be in compression, so there's not a whole lot of force going on between the 2 bulkheads. Make sure I'll get the edges here, but I don't want glue to come out in the step area because that'll interfere with the fit. So I'll just put one on top of the other, and I'm going to use this eye bolt here to hold the 2 pieces centered while the glue dries. There we go, and I'll get that tightened down. And I just have some simple spring clamps that I'll put around the edges as well to make sure that there's no warping. There we go, and I'll do the other one We'll let those dry and then we can get on to assembling the avionics. Alright, with my bulkheads cut, glued together, I've installed the U-bolts for attaching the recovery harness. I've also built an avionics sled. This is 4.5 inches in diameter, 8 inches long, plenty of room to install redundant dual deploy. So I'm going to get to work on that right now. As expected, the avionics installation onto the sled went really smoothly. That's one of the great benefits of working with a larger rocket, is that your electronics generally don't get any bigger, so you have a lot more space to work with, and it's super easy to set up these avionics bays, especially with redundant dual deploy. So just real quick, I'll talk about the equipment that I use. I'm a big fan of the MissileWorks altimeters. That's what I've mostly been using, so that's what I use this time as well. I've got an RRC2 Plus that'll be used for primary, and then an RRC3 for the backup functions. My batteries are from Hobby King. These are the Turnigi Nanotech 2S 180 milliamp batteries. I first started using these on my 5.5 inch Black Brant 2. They're 180 milliamp capacity, and I found on a typical flight they use about 20 to 25 milliamps. So they have tons and tons of capacity. They work great for firing the electric matches, and they take up a lot less room than a 9-volt battery. The switches are MissileWorks switches, and I'm using the screw guides on top of these because these switches are a little far away from the actual holes in the avionics bay tube. So the guides will help the screwdriver find the hole and turn on and off the avionics. I'm using 3-gram charge wells. This is from Doghouse Rocketry, and I purchased them off the Binder Design website. And then the terminals and the wiring is from Apogee Components. So I'm anticipating that 3 grams will be plenty for the charge wells. However, I also purchased some 6-gram canisters just in case these didn't work out. So we'll get this all put back together, and that should do it for the avionics bay. Like most cardboard kits, the LOC Patriot comes with a plastic nose cone. Now, to prepare the nose cone for paint, I first washed the nose cone with dishwashing soap and a sponge. Then I've gone over the nose cone with some sandpaper to help get rid of some of that mold release. That'll help the paint stick a little better. Now, before I move on to primer and paint for this nose cone, there's a couple things I want to do. The first thing is I'm going to drill out some holes in the base of the nose cone. This will allow the shock cord to pass through and create a stronger joint than just using this little ring here, which is not advisable on a rocket of this size and weight. The next thing I'm going to do is I'm going to glue in a few strips of this carbon rod here towards the front of the nose cone. That's in anticipation for using nose weight. I have a feeling with this rocket that it's going to need some lead ballast to balance out with the motor installed. Now the nice thing is putting in this carbon strips here is that if I end up not needing epoxy, it's not a big deal, but the strips will be there inside in case I need them. What I found works well to drill out large holes in the base of a plastic nose cone is a large step bit like this. This step bit goes to as big as 7/8 of an inch, and I'll just drill that all the way through, one on each side here, and that'll create a nice hole to allow the shock cord to pass through, and also it'll give me a nice large hole to drip in epoxy in case I need to add nose weight. So just a couple pilot holes. This plastic is very easy to drill through. And with my step bit, I'll simply just drill all the way through. There we go. A couple large holes. I can clean these up with a little bit of sandpaper here so as not to damage the shock cord, and that'll work real nice. Alright, I've selected a drill bit that's the same diameter as my carbon rod. So what I'm going to do here is just drill several holes on each side, and this will allow me to pass the carbon rod through the nose cone. And what this will do is it'll create a nice, strong mechanical grip for any epoxy that I might pour in. Now I've used a steel rod in the past on other rocket projects, and I had this carbon rod to use. And I decided to try it this time because not only is it strong, but it's a little bit easier to sand than steel. So that'll make it easier to smooth out the tip of the nose cone in preparation for primer and paint. There we go. Several holes in the nose cone. Now I'll just work the steel rod through. I'm going to epoxy it in place, and then I'll cut it and sand it smooth with the rest of the nose cone. Now before I install the carbon rods, I want to rough up the inside of the nose cone for applying the epoxy and the beads. So I've got my sandpaper on a stick. I can use the large holes that I've already drilled. Just kind of reach in there and do the best I can just to kind of scuff up the sides of the nose cone. Like so. Just kind of work the stick all around the edges here. And that's not going to be perfect, but it'll give a little bit more grip for the epoxy later. Okay, I mixed up a small amount of 30-minute epoxy. Now it's time to take my carbon rod and install it into the nose cone. So I'll just dip the rod into the epoxy here. And the nice thing is the rod doesn't have to be glued in too tight because there will be more epoxy coming when I install the nose weight. So there we go. Just put a little epoxy on the end and back it out. Like so. And I'll just leave a little bit sticking out. It's very easy to trim the rod once the epoxy cures. There we go. With my 3 pieces of carbon rod here, I'll just let the epoxy cure, and then I'll sand down the excess carbon sticking out. In this video I showed you how to turn the standard deploy LOC Patriot into a dual deploy capable rocket. Now truth be told, if you're ordering the kit and you want dual deploy, the best thing to do is just get the dual deploy option. But this is an option as well if you end up getting a standard kit and you decide later that you want dual deploy. Or if you have any rocket really that comes with a coupler that you can fit an altimeter into, it's a great technique to use to make it dual deploy capable. In the next video, we're going to do the final steps on the rocket, we'll get some paint on it, and maybe we'll even get it in the air. Thanks for watching.